Hi class, we're going to work on some exercises today from chapter 3. I'm going to share my screen with you. And I'm going to start with my Cengage screen. Today I'd like to go over exercise 318 with you. And this is the method of least squares, goodness of fit. You remember that we've been calculating methods that will help us to isolate the fixed cost and the variable cost through different methods. We've used the high-low method, and today we're going to talk about the method of least squares. The Deepa Dowdle opened a freestanding radiology clinic. She had anticipated that the cost for the radiological test would be primarily fixed, but she found that the cost increased with the number of tests performed. Costs for this service over the past 9 months are as follows. And what they've done is they've given you the number of tests that were done each month and the total cost of those tests. They've given you a range of months from January to September. In part number 1, they want you to compute the cost formula for the radiology services using the method of least squares. If required, round your answers to 2 decimal places. Well, the best way to do the method of least squares is to do it using a formula in Excel. So if you'll hold on just a second, and we'll stop sharing this screen with you, and I'm going to go to my Excel spreadsheet. Bear with me just a second. Okay, let me try this one more time. All right, you should be able to see the Excel spreadsheet that I prepared for exercise 18. And what I did is I just copied down the months and the number of tests and the total cost. Again, we're going to use regression analysis to perform the method of least squares. And so what you need to be aware of is in Excel, and it really depends on what version of Excel that you have. I have an older version of Excel. But what you would do is you would look at data, the tab data, and then find data analysis. So on your computer, it might be a little bit different depending on the version of Excel that you have. If you have read your textbook, you will know that they have given you different ways to look at Excel depending on the version of Excel that you have. Let me see if I can flip back through my textbook and see where that is exactly. There's a page where they talk to you about Excel. And it's over on page 100 and 101, where they will talk to you about the version of Excel that you might have. But this is an older version for me, and my data analysis is located under the data tab. So I'm going to click on data analysis for just a second so you can see the screen that's going to pop up here. And you can see they've got a lot of formulas that are built into Excel. I'm going to look for regression analysis because that's what least squares method is, the least squares method. When you find regression, click OK. And what it's asking you for is to input some of the cells that we've got here. What I want you to know that the y-axis or the y range is always going to be your cost. So what I'm going to do is I'm going to highlight only my cost for the months of January for February, and I'm going to place that into the Y range. That's the first box that they have right here. The X range is for the number of radiology tests. So if you were looking at this like a graph, on the left-hand side of the graph, vertically, you would see the total cost. And if you slide along the bottom part of the graph on the x-axis, that will be the number of tests that you're doing. But we're going to put this into a formula here, which will show us how easy it is to isolate the fixed cost and the variable cost portion of your total cost formula. So for input of the Y range here, I'm going to click on my cost in January, and I'm going to drag it down. I'm just going to click and hold it and drag it down to September. And you can see in the regression line here, it's got cell address C2 through C10. And then I'm going to click on the next box, which is the X range, and I'm going to put in my radiology test for January through September. You just click on it, hold the mouse down, and drag it down to where you can see where it's copying it into this formula. And I like to put it in a new worksheet. So what's going to happen is when I click OK, there's going to be a new worksheet that it builds for me with the data for the fixed cost and the variable cost. So this is the only thing that you need to put in, and then we'll click OK. And you can see that it created a new sheet for me in Excel, and this is the summary of my output. And what this does is it tells us some important information. You'll remember when we entered into our formula for total cost, we had fixed cost. The intercept is the fixed cost. So my fixed cost in this example is $36,588.82. This is going to be my variable cost per unit. Notice it's the variable and it's got labeled X beside of it. So if you've been reading your textbook, you know they like to use letters as symbols for the amounts that go into the cost formula. But this just stands for variable cost per unit. And so that's how easy it calculates it for you on Excel. So all you have to do is enter in the data and then copy it to the Excel formula, and it will prepare the summary output for you that has all kinds of important information on it. And so what the least squares method does for you is it will determine the fixed cost portion that they're asking you for in your Cengage problem. So I'm going to write this down for a second in case when I try to switch back to the Windows, I'm not real comfortable yet with the technology. And so I'm just going to write this down. So if you'll bear with me for a second, your fixed cost is $36,588.82. That's your fixed cost. And your variable cost per unit is $39. And they carried it out quite a bit, but I'm going to round it to cents because I think that's what they're asking you for in the formula. So if you'll bear with me just a minute, I'm going to flip back to Cengage and I'm going to enter this information in. So hold on just a second. I'm going to stop the share. I'm going to go back to Cengage. And in the formula that they wanted here, this Y stands for total cost. And Y is equal to your fixed cost or your intercept, which we found on that formula sheet for the regression analysis. That was $36,588. That's your fixed cost. And we're going to add to it our variable cost. Our variable cost is the variable cost per unit times the number of radiology tests. That's what the X stands for in this case. So what I want to put here is my variable cost per unit, and that came from my Excel spreadsheet that I showed you how to do that will calculate the least squares method with this. Now I'm going to check my work because sometimes they have funny rounding things. So let me check my work. And this is what they wanted for you to write down in Excel. But Y is total cost. Fixed cost is usually represented with an F. It is the intercept for the least squares method, and the variable cost per unit times the number of units produced, or the number of tests that we made, will give you the variable cost total. Once you have your fixed cost and your variable cost total, add them together, and that would give you your total cost. So it says, using the formula computed in requirement 1, what is the predicted cost of radiology services for October if they have 3,500 appointments? So basically you would put it in the formula where this is your fixed cost, and this amount right here, $39.48, would be multiplied by 3,500 units to get the total variable cost. So I'm going to pull up my calculator. Got a bunch of things in the way here, so let me see if I can scoot it over a little bit, moving stuff out of the way. Just bear with me. So what I want to do is calculate my variable cost, because this is my variable cost per unit. I need to multiply it by the number of tests, and in this case they're asking you to put in 3,500 for the number of tests. So 39.48, my variable cost per unit. Get that in there right. 39.48 times 3,500 will give you, it doesn't give you that, so 39.48 times 3,500 equals 138,180 is your variable cost. That's your total variable cost. So $39.48 times 3,500 gives you your variable cost. We're going to add the variable cost to the fixed cost to get the total cost. So I'm going to add my fixed cost of $36,588.82 together, and that's going to give you $104,768.82. And it didn't like that figure, so let me try to put that in. Oh, it wants to round to the nearest dollar. See, it got me there. So let's bump this up to a 9 here, and let's see if that'll help us. So it's 174,769. And that's what they wanted you to do for this problem. Again, this is the method of least squares, which is a part of regression analysis that you can do on Excel. So I wanted to show you how you did it on Excel. All right, so let me see what I want to do next. I'm going to stop sharing this with you for just a moment. And you probably are still seeing it, but I want to go ahead and look at the next exercise with you, which is 3.21 that I've got chosen to demonstrate for you. So you should be able to see right now exercise 3.21. And you can see this is kind of a lengthy exercise as far as it's wordy. So what I did in Excel is I copied all this information in. And so what we need to do is read this information carefully. It'll tell you a little bit about what they're trying to get you to do. So in the previous exercise, we did a regression exercise using least squares. In this exercise, the only difference is we're using multiple regression. So our formula for multiple regression is going to be just a little bit longer. If you look in part 1, they've given you y, which is total cost again, is equal to, this is fixed cost right here, this blank is, and then we're going to calculate our variable cost. Well, the only difference with multiple regression and regular regression is there's more than one type of variable cost that they're using. In this particular problem, we're going to look at 3 different types of variable cost to help us to isolate or to determine actually the total cost for this problem. So it's very important that you would read your instructions. And what I did is I copied this information into Excel because you can use Excel to help you to analyze this information. But before we go to Excel, I'm going to go ahead and write out the cost equation so you'll know what we're talking about here. This right here is what would happen when you entered the information into Excel. The only thing different that we would do for the least squares method, which was one method of calculating the variable cost, for multiple methods, you would just have several different items that you were using for your variable cost. Like for in the last example, we used the number of radiology tests to help us to determine our answer in 318. But in this answer, we've got 3 different variable costs, and they are given here. And if you put it in Excel, what you will do is you will just have a list of all your direct labor hours for the time period, and the number of wedding cakes for the time period, and the gift baskets for the time period. You copy all that information in the regression analysis formula, and it will do basically the same thing as what it does for a one variable cost per unit that we showed you how to do in 318. This one, they already did that information for you, so you didn't have to put it into Excel right here. So what this means here is this intercept right here that they've got is your fixed cost. So my fixed cost, which would be the first blank in the formula, will be 1,980. In the second blank that they've got here, this is the variable cost per unit. Now they figured the variable cost per unit for direct labor hours was $2.56. Notice it's got X with a subscript of 1 along with that. So we're just going to plug $2.56 into this formula. And this was our first variable cost would be $2.56 times the direct labor hours. Our second type of variable cost will be for the wedding cakes, and it's labeled X subscript 2. So it's $67.40 is what they want you to put here. And it would be multiplied by the number of wedding cakes. That's your variable cost per unit times, I like to call it the activity. So the wedding cake activity, the number of wedding cakes that we had times 67.40 would give your second variable cost. So this is your first variable cost, this is your second variable cost, and this is your third variable cost. The third one has to do with the number of gift baskets. The number of gift baskets was $2.20 times X subscript 3, which would be the number of gift baskets. So this would be an example of how the formula would be written out. And I'm going to click check my work just to make sure I've got everything in there like they wanted. And then in the next month, they want you to, in part 2, they want you to suppose that next month Sweet Dreams expects to have 550 direct labor hours. So in variable cost number 1, you would take the $2.56 and multiply it by 550 direct labor hours. For the variable cost 2, you would take $67.40 and multiply it by the number of wedding cakes, which is 35 in this case. For the variable cost 3, we would take $2.20. We would multiply it by the number of gift baskets. Once we had determined each one of the variable costs, we add all the variable costs together and combine it with our fixed cost, and that will give us an answer to part 2. So I'm going to stop sharing my screen again, and I'm going to go back to an Excel spreadsheet that I prepared that outlines this for you. So if you'll hold on just a second while I get my information organized. I'm going to stop sharing my screen. And I'm going to look for my Excel spreadsheet, and I will share this with you. So now you should be able to see the exercise 321. And again, I just copied this information into Excel. And when I copied it in, I tried to clean it up a little bit. This was the answers that they had come up with. And so I showed you what the formula would look like. And I kind of put my own spin on that formula. So I had it all written out as variable cost per unit 1 times the activity for unit 1. In part 2 was where we were working a while ago. And I set this up as best that I could for you, class. I'm not an expert in Excel, So I just did the best that I could with it. So my total fixed cost was $19.80. I got that information. It was given in the intercept right here is $19.80. That's where I get the fixed cost. And the number of the variable cost per unit for my direct labor hours was $2.56. So you have to calculate that. And so what I did is I took $2.56, as you can see in my formula bar, and I multiplied that by 550 direct labor hours. This would give you the variable cost for the direct labor hours. Then you would calculate the variable cost for the number of wedding cakes. And so the wedding cake variable cost per unit was $67.40. You would multiply that by 35 wedding cakes. That was the given information. And that will give you the variable cost for the wedding cakes. For the number of gift baskets, you can see the amount is $44. And what I did is I took $2.20 and then multiply that by the activity, which is the gift baskets. And then this part, they said that there were 20 gift baskets. So that will give you the amount of $44. So my variable costs are $14.08 plus the variable cost for wedding cakes, which was $23.59, plus the variable cost for the gift baskets. All three of these are added together, and then we combine it with the fixed cost, and that will give us the total cost for part two. So that's how they put it into the cost formula. And then they had a what if analysis for this. It says, what is your evaluation of the cost equation that was developed for the cost of overhead based on R2 in this equation? And so when you run the information through regression analysis, it will give you this figure right here for R2. And what that R2 means is basically that 92% of the cost are explained by the variable cost that you chose to analyze. So if this figure is close to 1, it's a good thing. So if this 92% is close to the number 1, it means that we probably have chosen a pretty good explanation for the variable cost portion of this formula. The independent variable is your variable cost. And so 92% of this formula that we put in to the regression analysis, it's saying that 92% of the variable cost that we have used explain the total cost. So the independent variable explains 92% of the cost. And I would say that that was pretty good. If it gets down, to like 75%, you might want to search for some other way to calculate your variable cost. In other words, you might want to see if there's something else that's driving your costs that you are looking at. And so in the next part, in part 3, in the next part of part 3, it says, suppose that Sweet Dreams charges an extra $2.50 to prepare a gift basket. This charge is in addition to the price charged for the items. that the customer chooses to put into the basket. So, you know, read your information carefully. I didn't want to take the time to read all of that out loud to you. I think you can do that. But they're asking you, can you compare the additional cost of a gift basket that was originally $2.20 that was determined in your regression analysis? Can you compare that to $2.50? And the answer is yes, that it is close to the price that's charged. So if they charge an extra $2.50, it doesn't seem like that price would be excessive, or it's not that much more than $2.20. But if they run into competition by competitors, they might look at less expensive sources that they are providing for their products. So in the basket, they might look for things that would cost them less money to provide the customers with the basket. And so that's what we do with these costs. We're analyzing the cost. But the main thing I want you to get out of this particular problem is that there is multiple regression. And you can do this on your computer, because if you had to calculate all this out, it would be cumbersome. And so you can use Excel to do this. And I would suggest that you use Excel to do with this. Play with it a little bit, class. That's the way that you will understand what you're doing here. So I hope this has helped you a little bit with this. I know that the textbook gets really complicated, but simplify things, that's what I like to do. And so the main thing is, you know, the total cost formula. Total costs are equal to your fixed cost plus your variable cost. In any regression analysis, that will work. So when you're choosing methods, the best method to choose would be the one that gives you the best line answer that you can draw from these different methods. So if you're using the high-low method, according to your textbook, it's one of the worst methods for isolating your fixed cost and your variable cost. A better method would be to use the regression analysis. But sometimes, you know, it just depends on what management is asking you to do. It's easier to calculate and understand the high-low method, I think, than to do this. But since you have Excel, it makes it kind of easy for you when you're working out isolating fixed and variable cost. So there's several methods in your textbook I want you to review. One of them is the high-low method, which we've done several problems using the high-low method. In fact, we did that in ACC 121. So you've seen that before. The scatter plot method, you've also seen that before. And this is where you just plot out the cost and you draw them in a graph. You draw a line through the most number of points that you can get to. According to your textbook, it says that the scatter plot method is better than the high-low method, but your best forms is regression analysis, which is what I've talked to you about today. So the most reliable estimate of your fixed cost and your variable cost is based on regression analysis. So again, I hope this has helped you a little bit. I'm going to stop sharing this with you, and I'll see you another time. Bye-bye.